Thank you, everybody. Um, my name is Faisal, as you introduced. And today we are going to talk about how you can deliver, how open source can deliver value to your business. A lot of time I see in customer meetings is the machine learning investments, initiatives doesn't turn into results, doesn't turn into business value. So we need to find out how open source can help you build that engine that can help your customers to deliver value as we go on. So I have written 3 books on Kubernetes and machine learning. So I always brag about that in the calls. And I work in AWS as a solution architect. Although this talk has nothing to do with AWS, just to be honest. And I've worked with Red Hat for 8 odd years. You can see my GitHub repository there if you want to see some of the talks that I'm going to talk about today in action. So when I was researching for this particular conversation with you, I've seen this awesome stats, and this is stat from 2023. And still, a lot of organizations that I see also at my role in Red Hat and AWS is they're not successful while delivering value to the customers, while delivering value for their organizations. And there are a lot of reasons for that. So, in today's talk, my aim is to explore together and help you see what could be the core verticals of the solution of the platform that you build that make you not put into this 85%. They want to make sure that if you are doing those perspective, your verticals, your organization will deliver business outcomes that you're expecting to get from your machine learning investments. This talk is not about providing ready-made solutions. You know, open source is a very fast-moving thing, as we know, even before the Gen AI days. So this talk about showcasing you what's available in the market and what perspective you should consider when you are building a solution, a platform for your organization. So remember, the ultimate goal is to be successful with machine learning. There's no point building 2,000 models if they're not bringing any more value for your business. So when we talk about machine learning, what's the first thing that comes to your mind? I would say models, algorithms, maths, coolness. You know, like if you see Hollywood movies, data scientists are pretty looking people building very complicated math. This doesn't happen in the real world, to be honest. So when you talk about machine learning being valuable for your organization, you should consider 4 key verticals, 4 key pillars. And we're going to talk about each and every pillar today and how open source helps you build those pillars within your organization so you can be successful in your machine learning journey as we go. So remember the number 4. I was watching one of the YouTube channels from Tesla, and one of the Tesla engineers actually showcased this particular graphic. And you can see here that on the left hand side, where the PhD title is the academics who are building the machine learning models, who are researching where we get most of the information from. The focus on building algorithms, building machine learning models is about 80%. But they put less focus on the data. If you are coming from machine learning background, you see we have very cool looking synthetic data sets like RX dataset, Titanic dataset, some data sets for image recognition, for example, in which ResNet has been built. But in the real world, the Tesla engineer says the focus is less on the model itself, more of the focus is required on the data sets. But you can see here in the real world is almost switched 180 degree. The model's focus is about 20%, 25%, and the remaining focus is on data. So when you are building your machine learning platform, you should be thinking about data as the first pillar, as the first thing, how you enable your team to process data, to process the right data for your models to be trained, and not only training data for model, but also how you capture the data while the model is being running in production for model drift, for data drift, and so on. So you should have a very good story when you're building an MLOps platform for your organization with data story around that, so that you can be successful in your machine learning initiatives. So this is the one of the synthetic data set I created just for this talk. Can you guys see how much problem existed in this data set? 4, 5, 6, 7, 8. Give it a go. Okay, so number is not important. Do you think this is a boring work or is the work you want to do? Yay or nay? So if you see here, we have duplicate IDs, we have incorrect data formats, we have invalid data, we have missing data, we have misspelled data, and we have a data that doesn't make any sense in terms of relevance. You cannot have 5 kids with 0 teacher. Although it's valid, it's not missing, but it's not correct. So you can see in the real world when I work with customers, 80%, 70% of our time is invested in fixing the data set, doing the data work. And to be honest, this is a boring work. Nobody wants to write code to find out if the empty is there or date formats has been checked or not. We have a very great open source library called Great Expectations. It's the real name of the library. It's a Python library that helps you define declaratively what kind of data checks you want to put in your data sets. So I encourage you to look into Great Expectations and see. So it actually helps you reduce the burden on your data teams to do this boring kind of work. And this work is so boring, Google has written a paper on that. You can see a paper by Google in 2021. Is nobody want to do the data work anymore. That's a Google paper. You can see the link on the bottom of the slide. So that tells you the problem in the real world when you talk about machine learning and why it's not delivering value for your customers is a good amount of work is boring work. Nobody wants to do that. So as an MLOps platform engineer, MLOps platform owner, what shall you do? What should you do to make sure that your teams are happy doing this kind of work? And this is one of the slides. If you know Andrew Ng, he's one of the father of deep learning. He done lots of courses on Coursera. He presented a couple of years ago in which he showed what we call it a very long tail problem. For most of the organizations, for example, if you're working with the banks, you're working in telco industry, you're working in government industries, you are doing fraud detection models, you are doing summarization using LLMs, you are doing context, finding out the bias in the data itself. And these kind of general problems are already solved with respect to machine learning models and algorithms. The models are good enough for that. And you can see here on the left hand side is where you have Facebook or Meta nowadays or Google's. They are on the bleeding edge of the stuff, right? But on the right hand side, you have your 90% of the organizations that the model is there, but they don't have relative data to actually train this model for them to work effectively. So when you are building your MLS ops platform, you need to make sure that you have a great data story so that your team can work on the long-term problem. So pillar number 1 for your MLOps platform is data. So data engineering is intensive. You have seen that. You need to have version the data, and you need to provide access data at scale. So what do you mean by versioning? For example, if you train a model with a particular data set, if you're training a new model, if you change the data set, you cannot compare and validate if the new model is better because of the new model or because of new data. So you need to version data and train model against them. And open source has a solution for data versioning. DBT is one library, Pachyderm is another library that can help you create a checksum of your data and version it against which you can go and train your model. Access to data at scale is also very, very important, and I'll show you a bit later. Is data comes in all kind of uh, formats, protocols. For example, Kafka has its own binary protocol, the CSV files, S3 APIs, NoSQL databases, RDBMS, IoTs. So to make your data engineer work more efficiently, your platform can abstract all these uh, combinations of protocols, of security requirements, governance. If you abstract all this, that will make it easy on your data engineer to do that work and ultimately be successful as an organization with your machine learning initiative. And you will see how open source help you deliver that. So that's the number one pillar when we are talking about building your machine learning platform. Now let's talk about the second pillar. So when you are building your machine learning platform, your data scientist, your product owners, your operations, SRE, application developer need to work together. So that's a pretty simple flow of building your machine learning model. Yeah, you can see product owner define what it requires. Then you have data engineers work with them to perform the data engineering jobs. Data scientists perform the machine learning model. You have deployment using developers and operations people, and then you have evaluation and analysis. In fact, this is the back of our mind is our MLOps platform want to enhance and work with these different personas. So can this follow this model while building your machine learning models in your organization? But in reality, it's like this. It's not a simple flow from A to B. For example, you first use a metric to optimize, you collect data and obtain labels, you train the models, and during analysis, you find out that you have wrongly labeled the data. You back to stage one, then you train the model again, and then you find out that your model has been trained using negatively biased data. Then you have to go back again and fixing the data and train the model. And by the time you go into production, you have trained the data on a very old data set, you have to start it again. You can see the complications here is you need to provide a platform that can not only help teams to share results, but also be iterative in a very efficient way. I've seen data scientists who actually run the model, find out the performance of the model, and then upload a CSV file into a Git repository, and then email somebody, hey, this is my model requirement. That's slow. There's no connection with the data with the CSV file. There's no connection with model versioning with the CSV file. So that's not very effective, and that creates slowness in the overall life cycle of your model development. So the second pillar your MLOps platform should be considering while doing performing building platform for your organization is model development. And the key to there is it has to provide iterative way. It has to provide how people work together, how they share results, how they share resources. I've seen data scientists using TensorBoard for sharing resources, somebody using MLflow, somebody using CSV file. So the platform is an opportunity for you and an organization to standardize on open source components so people can share and validate results in a standard way. And a third is a very important thing is managing hardware. GPU is a very expensive resource. So you don't want the GPU to be allocated to the data scientist who's went out and not using that GPU for that particular half a day or something. So you want to have a dynamic allocation of GPUs to the data scientist on demand and see how your platform can enable you doing that. That's a second very important thing called model development. Here, you need to provide a way for your teams to go and share resources, share their learning, and experiment faster while building a machine learning platform. The third pillar that I want to talk about is inferencing. Now, you can see a lot of people focus on uh, building models. I have a customer, they are building around maybe 30 to 40 models a week, but their inferencing is 1 billion calls per month. So, most of the cost that comes in, the business cares about, the optimization their customers see is on inferencing level. So you need to find out a platform that can help inference the model that is built by data scientists. So data scientists are not developers. When they want to deploy a model as a REST service, does your platform provides a capability for them to actually go and deploy a model that can be consumed as a REST service? Does your platform provide a capability to execute a model in batch way? Does your platform provides a capability to capture the data drift? So data drift is what I'll give you an example. Um, so there was a company who trained how full is your bus based on time of the day. So they were if you use their app, they'll tell you okay how full the bus would be. You say okay I'm going to catch this bus for example today, and it will tell you okay it will going to be 20% full, 80% full, 90% full based on the time of the day and based on the data that they collected over the years. Then COVID-19 happens. After COVID-19, nobody's traveling. If you open the app, you still say 90% full. The bus is in fact 0% full. There is nobody beside the driver. So that we call is a data drift. The real world changes. The real world data changes all the time. So you have to keep on understanding if the actual data that you are inferencing on is kind of representative of the data that your model is trained upon. So you have to compare that during inferencing. If there is too much deviation, you should generate an alert to retrain your model. So inferencing is not about just delivering the model or what model is delivering. It's about calculating the data drift. It's about calculating the model drift also. For example, let's say you build a model that's doing fraud detection, and generally, let's say it's 90% correct. But for the last 2 weeks, it is only 80% correct or 70% correct. It means something is changing. The model is drifting from the standard metrics that you are comfortable with. So you have to calculate that. You have to make sure your model is delivering value to the customer, and that's what I talked about capturing data drift and model drift. So you have to have an inferencing system that can capture the model drift and the data drift, so you can trigger retraining or capturing new data from the real world system. And the last but not least is batch and real time inferencing. Still, I see in the market over 80% workloads are uh, batch based inferencing. So you receive a huge file of 1 billion records, 100 million records, and then you find out what's going on. So when you're talking about inferencing, you have to provide all these capabilities so that your team does not need to build these capabilities from scratch. The more your platform provides, the more successful your organization would be in the machine learning journey. And I'll show you a couple of projects like Selden Core that is providing this capability to capture the inferencing data, model drift, doing batch and real-time inferencing, and ease of deployment. So we have talked about data, we have talked about um, model development, and we talk about inferencing, right? These are three major pillars. There's one more pillar, and I'll tell you a story about that to understand how important it is in the real world. Is I was working with a customer. They have a team of around 10, 11 data scientists, and they run around 60 to 70 models, right? So if you do very simple linear analysis, one data scientist is responsible for 6 to 7 to 8 models, and that includes retraining, that includes validation, that includes data engineering, that includes inferencing, everything. Now they want to scale from 50 to 70 model to thousands of models. Do you think they need to hire on the linear scales to hundreds of more data scientists? That will move them out of business. So a platform need to worry about how the repetitive work can be automated, so your expensive resource like data scientists and data engineers can be put on more higher value work. And that's a fourth pillar of your machine learning platform. That pillar provides a workflow engine, so you can retrain the model on the newer data, for example. You can crunch the data when the new data comes in. You can do drift calculation, and you will see how effective your model is in production. So workflow is one of the factor that I think is missing across a lot of customers. In automation, whatever can be automated, so you can scale. So the number of models should not be a linear relationship between your data scientist or the available hardware. So these are the four major uh, verticals that you can look into. You have to take a look while building the machine learning platform. So the next question that you can ask is, hey, um, so what? Cloud actually provides all these things. If you go to Google has a Vertex platform, AWS has SageMaker, Azure has Azure AI, other vendors also has some platforms. So what open source delivered that is not there already? And that's the biggest benefit of open source is cloud vendors wants your data to move to their ecosystem, and the data is not always movable. There like you have lots and lots of data. There's a lot of cost involved. There may be involved about you cannot move your data out of your country. There may be regulation requirements around your data. The benefit of open source is it provides all these four verticals that we talk about, and you can run this within your data center if you want. So you have cloud-like capability, you have all these workflow, inferencing, model development, and data engineering as a part of your current ecosystem. And that's the biggest difference that open source can bring to you. And you think about that, I've worked with a lot of customers. Moving data from the data center to the cloud is a task that can take years, easy. And there are so many regulatory requirements, there is more security requirement, governance requirements. So the change that open source can bring is all the software is available as an open source. You can run where your data is. So that's the biggest difference that open source can bring. Okay, so let's go about a little bit of implementation. So I'll talk about couple of products that actually help build those four pillars, and then you can have an idea of how you can build your own machine learning platform. So these are the four verticals that we talk about: data engineering, inferencing, training, workflow. Now it will contain a lot of software components to manage, right? On top of that, you need some standard running software like auto scaling, security, data operations, self-service. So how do we bring on all these capabilities and merge with these components so that we can work in a one cohesive kind of ecosystem? And that's what Kubernetes actually plays the role. So Kubernetes provides a bottom layer. If you deliver all the software as container, which is already available, then don't need to worry about auto scaling, don't need to worry about security, data operations, and self-service. You can use the existing proven pattern of Kubernetes and apply it to the software that actually fulfills the void for those four pillars. And the next question that I've been asked is, all right, so we have Kubernetes, we have the bottom layer catered, but on the top layer, the four pillars can provide complications, right? Data engineering can be 5 software, inference can be a combination of 3, 4 software, then workflow, training. How do we manage all this software, right? That's what the Open Data Hub comes into picture. Open Data Hub is a meta operator that works on Kubernetes, and that helps you deliver those 4 verticals within your Kubernetes ecosystem. So again, open source is enabling you to be more productive. Open source is enabling you to be more relevant to your data science team, to your data engineering team, to your business, so you can deliver value, or you have prepared them so you can deliver value faster. Keep an eye on always when you're doing any work, make sure that you know what's the outcome for that with respect to business. Now let's see a little bit deeper into how certain software can work around that. So imagine I showed you that synthetic data set, if you remember, right? Now that data set was easy to understand because I built it. But imagine it's a COVID-19 data set or some very specific data set that's related to manufacturing or any other specialized field. We as a developers, we as a open source enthusiast cannot add lots of value into that because we don't have the relevant information. We don't have the SME knowledge. And the SMEs are doctors, are engineers who don't want to write Python or Go or Java code. So how do we merge these two? And that's what these components actually work a lot. So Apache Superset is a drag and drop based application where people can drag and drop and do exploratory data analysis. They can write queries via drag and drop or via simple SQL. And what Apache Superset does, you can connect with an open source product called Trino that helps you access all kind of data using simple structured query language. So think of Superset is a tool that actually write SQL behind the scenes using drag and drop. And Trino is the one that abstract all the data protocols, security requirements. It provides governance also. For example, who can access what. So these two open source component will help you build a full. You guys still see it or gone? Okay. Will help you build a full story on exploratory data analysis in the data engineering vertical. Right? So Trino provide governance. Trino provide abstract to actually talk to different data protocols like RDBMS, Kafka, S3, CSV. And on top of that, your SMEs can use Superset to actually use that capability to do that work. And they are available now. They are available in Open Data Hub. You can go and try it out in the your Kubernetes cluster. That's number one part. Number two is, okay, you provide a capability to help. Oh, okay. Slides are gone somehow. Got it? Oh. All right, sorry guys. Okay. So you're able to see the previous slide or not? Yeah, okay. So next slide is, again, there's a data engineering vertical. Imagine I showed you the data engineering is a boring job. So how do you facilitate your data engineers so they can do their jobs while still interested? Right? So one way of doing that is to help them do their job faster. So they can write Spark code, for example, or Ray code, for example, right? And Kubernetes and open source Spark controllers that come with Kubernetes can take care of managing Spark cluster at scale. So the data engineer doesn't need to worry about Spark, doesn't need to create a ticket to have a time on the common Spark cluster, or doesn't need to worry about, okay, give me the Ray specific hardware. The open source controllers running on Kubernetes can automate that job. So your data engineer can write the normal Python code and everything around that will be taken care for him or her. So that's also available right now within the open source framework using Open Data Hub that I mentioned. Google has written the Spark controller that you can also use as a part of your MLOps journey. And while writing the code, they can write on their laptops or they can use Jupyter notebooks. That is available in Open Data Hub as a service. You can log in. It provides a single sign-on with your IDP, and then you can start building the code as you go. So the open source provides you not only writing the code, but also executing the code at scale with a minimal, which provides maximum abstraction and minimal involvement. So that will help your data engineer to be more productive while using open source. These are the verticals about data engineering. Similarly, you can use Jupyter notebooks. Data scientists can use Jupyter notebooks. Now, Kubernetes has and NVIDIA has options to actually allow specific GPUs to be dedicated to a particular container. So if you have a box with a one NVIDIA hardware with, let's say, 20 GPUs or 10 GPUs, so you can select using open source tools to one GPU allocated to one notebook, and then you can manage the hardware that way. And Kubernetes can do it for you out of the box. And your data scientists can build their machine learning code using TensorFlow, PyTorch, whatever library they want, using Python and Ray. There's one important component I want to show here. It's called MLflow. So MLflow is another open source component that help you build a registry of your models. You can do model versioning. It can capture the hyperparameter against the model has been trained, and it will capture also what are the evaluation criteria of the model itself. And it is tightly integrated with TensorFlow, PyTorch, and scikit libraries. So a data scientist doesn't need to do a lot. They just need to have one line in their notebooks, and all the data will be captured automatically in MLflow, which you will be able to share across teams. So remember, like, sharing and experimentation is a key for data scientists to be more productive, for your MLOps platform to deliver value for your business, and that you can do with a component like MLflow. Now the third is, okay, your model is trained, it's available in MLflow in a registry. How do you inference? So we have an open source product called Seldon Core, Seldon, you can see on the screen, that actually help package your model as a container automatically. It can go to your S3 bucket, it can go to MLflow, download the model and expose that as a REST API, or you can also run the model in a batch inferencing mode using this particular library. Now again, there may be more libraries coming as we go because it's a fast moving field, but keep the focus on delivering value to your organization. Is now if the machine learning model is ready, you don't need to talk to app developers and have a lengthy process to package it as an app to be consumable. It can be done automatically via your automation using Seldon, for example. Batch and REST both. And if you remember in the inferencing, one thing I mentioned about data drift and model drift. So Seldon can capture the input and output and forward it to your data stores like Kafka, like S3, where you can run analysis on if the drift has been happening in the data or the model itself. So that connectivity, that integration is part of this library, and it can run as a container, so you can use it today with deploying your models. And the last but not least, the fourth pillar is the workflow. So you can have multiple workflows to actually automate the things. If you remember the story of scaling up your data science team. So Apache Airflow is one such product. Kubeflow is also very popular nowadays. So what it does, for example, I see these three pipelines or these three workflows. The first one is deploying the model. It can download it automatically, build and package using Seldon and deploy it. So you don't need manual process around that. When the new data set arrives, you need to crunch that data, right? So generally you have to get time in the Spark cluster and then get some approval and run it manually. So with Kubernetes and Open Data Hub, when the new data arrived, you can trigger this pipeline. It will spin up a Spark cluster on demand without any involvement. It will run your data jobs, and it will stop the Spark when data job is done. So that you can do further. And the last one is, if you want to retrain your model with the new data, if you remember, there's a model drift and the data drift. So when the new data is available, it can automatically run your training notebooks, and you can go ahead and upload in the registry from where it can be available. So all these things you got to do to make more productive of your expensive resources, data scientists and data engineers. And these doesn't need to run in isolation. They need to be connected with each other. So you need a software component that helps them to reconnect with each other. So Apache Airflow can do that using its DAG modeling techniques. And the last slide is, you don't need to build everything in open source. Open source is there to enable you to be successful. For example, if you choose to use Google Cloud to train your model using their Vertex platform, for example, open source is not stopping you to that. It's not a 1 or 0 kind of thing. It's to enable you to be successful. You can choose Google Cloud, for example, And this is a very simple example. It's no recommendation at all. It's just an example I built on. Is use BigQuery, Vertex AI to train your model. Then you use Amazon to inference, maybe because they have more hardware choices. And at the edge, at your shops, at your factory floor, when there's no availability of your cloud, you can use OSS to actually inference at the edge. So the idea is once you know all the 4 verticals, you know the components that are available for these verticals, then you can mix and match with your existing world. Think about from that perspective. You don't need to adopt all of them or some of them. You see where the gap is, and open source will be there to help you out fill this gap. So that was the last slide. Open to questions. Any questions, guys? Thank you very much.
Making way up.
What silence it is, or we have questions?
Yep, okay.
Hey Faisal, I like at the end you showed like a deployment option leveraging multiple platforms. With some of the things that you've walked us through, just how portable are they between the various providers? Because right now, one thing I'm hearing is a bit of a lack of GPU resources for running a lot of these models. And something you mentioned is, if you've got GPU resources, trying to make sure they're being allocated appropriately. How does an organization try and design something that they can be effective and as portable as possible, given the scarcity of some of these resources today?
It's a great question, and we see it especially in Amazon recently. So again, open source is the answer. You deploy your models as containers. That's number one. Container is a portable format that is supported by all the major cloud vendors. The other thing, no matter how much social media tells you, NVIDIA is not going anywhere for at least the next decade. They have a very tightly coupled CUDA library with their GPU resource. So if you are doing machine learning, they have capabilities like TensorRT. You need to recompile the model, and it will run maybe twice more effectively as compared to just running in the CUDA as a core. So use containers, and if you are using GPU resources, you can use CUDA or TensorRT, and that will be compatible across multiple vendors and across open source component. Having said that, there are some specialized things. For example, AWS has inferential machines where they have Neuron SDK. You have to recompile the models on that, right? So to start with, if you want compatibility, go with NVIDIA, go with containers, you'll be okay with that. Any other question?
Nope. Okay, everybody, one more round of applause, please.
Thanks, everybody.